I'm Dr.B.Krishnaveni, Assistant Professor, Department of Mathematics, Aditya University. So today we are going to discuss about triple integrals. How to evaluate triple integrals, that is along x, along y, along z. Today learning outcome is, at the end of this lecture, student will be able to know how to evaluate triple integration. So let's see what is meant by triple integrals is. Let us consider any function in three variables x, y, z. Be a continuous function at every point in a closed and bounded region D in space. So the triple integral over D is denoted by triple integral over D f of xyz dv, and the same can be represented with triple integral over D f of xyz dx dy dz. As in the case of double integrals, the triple integrals is evaluated by three successive integration of a single variable. So here you can see the triple integrals means we need to integrate three with respect to three variables. That means first we need to integrate with respect to one variable by keeping the other variables constant, thereafter with respect to the other variable, finally the last variable between the given limits. So now let's see how to find out the triple integrals in each of the cases. The first case is if all the limits are constant. That means the triple integral takes this form. That is integral a to b, integral c to d, integral e to f, f of x, y, z, dx, dy, dz. If all the limits are constant means the integration can be performed in any order with the proper limits. So you can follow any order to do this, but the best thing is if all the limits are constant means you can follow the same order given in the question itself. So here x limits, the inner limits, next inner limits will be the y limits, finally the outer limits will be z limits. And now the second case, if x limits are in two variables, that is yz, y limits single variable, that is in terms of z, and finally z limits are constant. If this is the case given, and now to identify the limits in this case, just as a double integration, if the limits are in terms of x means we are telling those are y limits. If the limits are in terms of x means we are telling those are x limits. The same pattern here, the limits are in terms of yz. So obviously which limits they are? X limits. So x completed, the next limits are in terms of z means definitely that should be y limit, and finally which are constant, that will be belonging to z variable. So in this case, first you have to integrate with respect to x, which is having two variable limits, by treating y, z as constants and substitute the limits of x. Next, integrate the resulting function with respect to y by treating z as constant and substituting limits of y. And finally, we need to integrate the resultant function with respect to z and substitute the limits of z. So in this way, we need to proceed if the variable limits are given. The only thing is here maybe x limits are two variable limits, y limits are single variable, z limits are constant. So that's what we have taken first with respect to x, then with respect to y, finally with respect to z. So how to do this means, first of all we have to do the triple integration with respect to the variable having two variable limits. Next with respect to the variable containing single variable limits, and finally with respect to the variable which contain constants. So in that way we have to check the given question and you have to evaluate the triple integrals. So now let's discuss the question. The first question is all about finding the triple integration which having constant limits, and is given by integral 0 to 1, integral 0 to 2, integral 1 to 2, x square yz, dx dy dz. So here it is very clear that the same order we will take. So x limits 1 to 2, next y limits 0 to 2, and finally this is z, and this is the z limits 1 to 2. So let us do the integration. You can separate in this way to make more easy, that is integral 0 to 1, integral 0 to 2, integral 1 to 2, x square yz dx dy dz is equal to integral 0 to 1 z dz, integral 0 to 2 y dy, integral 1 to 2 x square dx, which is equal to z with respect to z means z square by 2 between 0 to 1, y with respect to y, y square by 2 0 to 2, x square integration is x cube by 3 between x limits 1 to 2. Substituting the limits in each case, the first one, upper limit is 1 by 2, lower limit is 0. Second, upper limit is 4 by 2, lower limit is 0. And in the third, 2 cube by 3, that is 8, minus lower limit x is equal to 1, which is 1 by 3. Simplify, you got the answer, that is equal to 7 by 3. So this is the question which we got an explanation to find the triple integration in which all the three limits are constants. The question in which having variable limits. So the one is having two variable limits, the other is having single variable, the other is having constants. So here clearly you can see triple integration. The first limits are from 0 to root of 4z minus x square. That means the limits are in terms of xz, means those are y limits. And the next limits are in terms of z. So y completed. So you are left with the two more variables, that is xy. So you can take those are x limits since the order is given already. And finally the constants which are z limits. Hence the order should take as dy, next x, next z, that is a dy, dx, dz, the same order which is given in the question. So let us do the integration first with respect to y, keeping x, z as constants. That gives integral 0 to 4, integral 0 to 2 root x, integral dy is y, limits 0 to root of 4z minus x square dx dz, which is equal to integral 0 to 4, integral 0 to 2 root z. Now substitute the upper limit y, that is root of 4z minus x square dx dz. So now next do integration with respect to x. So now doing with respect to x means we have to keep z constant. So now it is in the form of a root of a square minus x square. And what is an integration of root of a square minus x square is x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. So here what is a is 4z, a square is a 4z means a is 2 root z. Okay, by taking this we can find out the integration of this root of a square minus x square, which is given by x by 2 root of a square minus x square plus a square by 2, that is 4z by 2 sine inverse x by a. What is a is 2 root 2. Now what the limits of x are? 0 to 2 root x. Substitute the limits now. X by 2, that is x is equal to 2 root z, upper limit, that is a 2 root z by 2, 2 to cancel root z, into square root of 4z minus x square, 2 root z whole square is 4z plus 4z by 2, which gives a 2z, sine inverse of x, 2 root z by 2 root z, that is a 1, upper limit this is minus, if we substitute x is equal to 0, the lower limit is 0. Now this will be equal to, so root 2, 0 means it is a 0, the first term becomes a 0, 2z into sine inverse 1, so sine inverse 1 means pi by 2 it is, 2 gets cancelled and you are left with z pi, pi is constant, take outside the integration. Now do integration with respect to z, z integration is z square by 2, the limits of z are 0 to 4, which is equal to pi by 2, upper limit z4, 4 square is 16 minus lower limit is 0. Simplifying, you got the answer is equal to 8 pi. So hence we got the thing in this lecture is how to evaluate the triple integration, and we discussed the questions regarding constant limits as well as variable limits. And we got an idea how to take the order of integration and how to evaluate triple integrals. Thank you.